Welcome to lesson 5.4, fitting a line to data. So in the last few lessons, we looked at different ways we can write linear equations given a slope, a point, or 2 points. So now in this lesson, we are going to look at what we do if we have numerous data points and the fact that if all those data points do not line up on a single line, how do we approximate the data, or how do we come up with a good estimate? That's the main idea for today's lesson. So what we end up doing is we create what is known as a line of best fit. And a line of best fit is a line that splits a scatter plot approximately in half or averages, to the best of your ability, the different data points. So how do we create a line of best fit? Well, the first thing that we need to do is to plot all the points of data on a graph. So take a minute to pause the video and to graph all these different coordinates. You can see I already did so on my graph over here. So you have 1, 2, 3, 4, 5, 6, 7, 8, 16 different points to graph. Once you're done plotting those 16, hit play again and we'll move to step B. In step B, then, it says use a ruler to sketch a line that you think best approximates the data points. Now, as you're drawing this line, which you'll see in step C, you want to do, if possible, is have the line cross through a few data points, or XY coordinates, that are whole numbers, not decimals. So for example here, all the pink points are my data points. You can see the green line that I drew started at the point 0.4. It also went through the point 0.25, through the point 0.46, through the point 0.67, and so on. So my line of best fit that I drew does not have to hit original data points necessarily, but it needs to best split your data points in half. So the goal here is to try to hit a couple of the data points if possible, but then to have equal amounts roughly of data points on top of the line and below the line. So you're drawing in a line that approximates the data. So then in part C, like it says, you want to locate 2 points on your line. Approximate the X and Y coordinates for these points. So these don't have to be original, but you want to try to choose points with whole number coordinates, not decimals or fractions. So you can see on mine, I had 5 different data points I could choose from that my line of best fit went through. So you're choosing 2 points on the line, not your original data. Once you have those 2 points, then we can do what we did in lesson 5.3 and write our equation. So first thing to do, plot all your data. Second thing is use a straight edge or a ruler to draw a line that best approximates or splits the data in half. Locate 2 points on that line. So we have the X and Y coordinates for the ordered pairs. And then we come down to part D here, which is going through the steps in 5.3 to write our equation that passes through the 2 points. So the 2 points that I decided to use were the 2, 5 and the 4, 6. So the 2 points that I'm using for my slope come from the 2, 5 and the 4, 6. So on top, change in y would be the 6 minus the 5 from my 2 points. On bottom, 4 minus 2. So that tells me the slope of the line of best fit is 1/2, or up 1, right 2. Then we need to solve for b, or our y-intercept. So we know the slope is 1/2, so our equation would be y equals 1/2 x plus b, and you can pick any of your data points on the line to put in for x and y. So I'm going to use 2, 5. So the 2 goes in for x, the 5 for y. 1/2 times 2 is 1. So on the right, we have 1 plus b equals 5. Subtract the 1 from each side, and b would equal 4. So our equation in y equals mx plus b, slope-intercept form, would be y equals 1/2 x plus 4. So we took all the random data points for this scatter plot, drew our line of best fit, picked 2 points off that line, and then we figured out the slope and the y-intercept to write our equation. So once you draw the line, get 2 points off of it, and the rest of the process is the same as lesson 5.3. In example 2, they say state whether x and y have a positive correlation, a negative correlation, or no correlation. So 3 examples of each. If all of our data can be drawn with a line of best fit that's going up left to right, so the data is rising left to right and we can put in a line of best fit, we call that a positive correlation. So the slope of that line would be positive. If going left to right, our data is all dropping and the line of best fit goes down left to right, so if the slope is negative, we have a negative correlation. And if our data is so spread out that we cannot approximate a line, that is known as no correlation. And then we get down to example 3, kind of our last examples for today, because example 4 we're going to skip. It's the exact same thing as example 1, just different numbers. So in example 3, it asks us to draw the line of best fit, then write the equation of the line. So they gave us all the data points. You can see the line of best fit that I drew in. It actually hits 1, 2, 3, 4 data points from the scatter plot. So I'd say it's a pretty good line of best fit if it's hitting 4 of the data points. Then what we want to look at is picking 2 points off the line that we drew. So I chose the point 1, 1, and then -1, 3. So I'm first going to figure out the slope of my line. So change in y over change in x. So on top, 3 minus 1. On bottom, -1 minus 1. That gives me a slope of 2 over -2, which simplifies to just a -1. So my slope, or m, is a -1. Then I need to figure out my y-intercept. So I need to choose a point from my line to plug in to get my y-intercept. So I'm choosing -1, 3 to solve for my y-intercept. So our equation would be y equals -1x plus b, and we're going to put in a -1 for x, a 3 for y. So 3 equals -1 times -1 plus b, or 1 plus b equals 3, so we subtract the 1, and b would equal 2, which if we look at the graph, you can see my y-intercept is at 2. Slope, down 1, right 1, down 1, right 1. So y equals a -1x plus 2. Now in part B, again, this is all the same thing as 5.3, except first you need to draw your line of best fit. So drawing your line of best fit, and you can see mine hits a few data points, 4 again, and roughly splits the data in half. Choose 2 points off your line of best fit. For mine, it's 0, -4, and 2, -2. Then I'm going to figure out my slope. So -4 minus a -2 on top is -4 plus 2. Then on bottom, 0 minus 2. That gives me a -2 over -2, which simplifies to a slope of 1. So now that I have my slope, I need to figure out my y-intercept. So in this case, we could set it up as y equals mx plus b again and do what we did in part A. Or as I mentioned, if you can look at your graph and see your y-intercept, you don't need to solve for b. We can just take it off the graph. So for example here, I know I have the point 0, -4 on my graph where my line is. So if I have a 0, -4, my y-intercept is at -4. It crosses the y-axis at a -4. So I could have set it up, plugged in a point to solve for b, or I could just look at my y-intercept if it's on the graph, and it's right there. So in this case, our slope is 1, y-intercept is -4, so the equation would be y equals 1x minus 4. And like I said, you can skip example 4 because it's a repeat of what we did in example 3a and b, along with the first example up here. So the main idea to today's lesson is that idea of a line of best fit and our types of correlation. And the rest of it is exactly what you did in lesson 5.3 with writing an equation given 2 different points.